record in the session for those who cannot attend at this moment. No sound. Please, can you give me a sign? Can you hear me? All right. Okay. 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 Thank you very much. So today, actually, we are going. We'll try not to make it for 1 hour, 1 hour and a half. We'll try to make it a little bit short. And the first objective of this workshop is to show you how it is easy now to introduce Tinkercad for our students, starting even from grade 7. I know that we have participants that they are using our curriculum 01 or right click, and there is other schools, other teachers that are not using till now. Hopefully, in the near future, they will move to our curriculum once they discover more and more how it is attractive and how it is simple for this integration at your school. The main purpose of using Arduino in the curriculum is to expose our students to microcontrollers, which is the main gate for understanding what is IoT and machine learning and artificial intelligence, and of course to create a project, STEAM project at school. For science fair or for other event at the school. Before Corona, like before 2019, let's say, it was like impossible for schools to teach Arduino for lower grades. I mean lower grades 7, 8, 9. Why? Because there were no software or no application where simulation was available, or it was like a bridge between the concept of Arduino and the hands-on. And the teachers who were using Arduino at that time, they know very well that it's like impossible to make students create circuits like this one, to create circuits like this one with cables and with wires in order to create a Arduino circuit. So do we need physical things? Of course, I will explain during the session. So once Corona is here, and one of the advantages that we had from Corona is like that Tinkercad, which is a company of Autodesk, created what we call Tinkercad. And this Tinkercad is divided into 3 main parts, which are 3D design, as you can see, circuits, and code block. And I believe you can see my screen. No, please, can you approve me on the chat that you are sharing my screen? All right, great. So the first advantage of Tinkercad, it was like teacher can create and can make students understand what is the concept of Arduino, to create simple circuits, as we will see now, and later on to move from the theoretical part, the simulation part, to what we call the physical part. So as a start, you have to know that like 80 or like 70 to 80% of the concepts that students must learn in Arduino are concepts of comprehensive understanding. What is Arduino, the input and output devices, what is the breadboard, resistors, sensors, motors, and all those stuffs. This is first. Second, they have to know what we call how to create the circuit. And once the circuit is created virtually on the screen, it will simplify the task to move on later by building the circuit with a hardware using the cables and the Arduino boards and the breadboard and other electronic components. And today I'm going to show you how, if we create a simulation program on Tinkercad, how it is simple to move on and to make it a real project using the hardware directly. So first of all, I will start by creating a new circuit page, just in order for those who are new with us, because we did already before a session for Arduino, but I'll try now to make like a summary for this, and then we will move to the curriculum to show you how easy the implementation is. So once Tinkercad is open, the first thing I will do is to move an Arduino board, and then as simple, I will move the LED. And as you know that the LED has two legs, the first, which is the cathode, and the longer one, which is the anode. So the cathode should be connected to the ground pin, and the anode should be connected to one of the 13 digital pins that are on the screen. So I will take the LED, I will click and place. I'm recording the session. And at the end, I will send it to all the teachers that are with us and absent. And for the anode, I will click and link it with a wire cable directly to the LED 13. So this is the first, let's say, a project that you are asked to do with your students with Tinkercad. And if I move to the code, you will see that the code or the interface is like a Scratch, which will simplify the task for creating the code for the circuit. So as you can see, in the forever loop, you see that there is 4 blocks built in already in the forever loop, which are the set built-in LED to high, wait 1 second, set built-in LED to low, wait 1 second. And once I click on start simulation, you will see that the LED start blinking. And the LED on the board, which is the LED 13, that you can see, I will show it to you, this one. So this is the LED 13, which is connected on the board of the Arduino board. So in case I stop my simulation and I ask the students to move the cable and to put it to digital pin 10, we will discover the ground. The ground is the negative pole, which is, as you can see, or you can know that each LED to make it blink, you need the plus sign and the minus sign. So the ground is the negative board. So if I run again the program, you see that the LED on the board will blink, but the external LED does not blink since it is connected to digital pin 10. So here I go to my code. I will add the set pin, and I choose 10 to high and set pin 10 to low. And once you click on run, you will see that the 2 LEDs are, sorry, I forgot to put low here. So start simulation. So you can see that the 2 LEDs are blinking. Can you tell me on the chat if this manipulation is a simple manipulation for students in grade 7? Can you confirm what I'm saying based on the knowledge that you have Exactly. It's really simple. So once we go through this example, I can introduce the resistor, which is the element to protect the lead not to be burned, since the lead does not need as much current as the breadboard is giving. So I will remove my cable, and I will link it in this way. I will select the resistor, and I will choose the value ohm 220. And if you are going to ask me why 220, I'll tell you this is a electricity concept that the science teacher should explain to students, since we are ICT. So once I click on the start simulation, you can see that the LED is blinking, and there is no warning message on the LED. So it's protected now. And this is the second project, always by simulation. I will not move now to the hardware. I will keep it to the servo motor and to push button, in order to show you how easy it is to move from one term, which is the virtual, to the hardware. I will stop the simulation, and I will show in a third lesson why the breadboard is needed. So I will take a breadboard, which is like the electricity socket, in order to put many wires there, because on the Arduino board, I'm not able to put as much LEDs as I want. So I will take the first LED, I will take a second LED, and I will take a third LED, and then I will take one ground, then I will place it on this row, and as you can see, all the dots in the row below are connected horizontally. So you can assume that all the dots here, or all the holes here, are connected to ground. So from here, I can take one cable for this LED, another cable for this LED, and a third cable for this LED. And you can see it is clear. It's not very complicated. So students now can understand how to introduce the breadboard in the Arduino concept. All I need now is to add, let's say, a resistor. I will copy paste another one, and copy paste a third one, and I will place it like this. So each LED now, it has a resistor, and of course I was supposed to make it ohm 220, the right value for the LED. So I put the 330, and then after I will connect my first LED to digital pin, let's say 7, and then 9. Here it's up to me to choose which port I'm going to select. You can select the digital pin that you want. It's not an issue. So here 12, 9, 7 are connected to the 3 LEDs. So I go to code, and then I will duplicate this one. Sorry, excuse me, it's wrong. So duplicate. So I'll put 12. I'll put 9, and then 7. Okay. After that, I will go to control and to place a wait block, and then I will duplicate all and to put them to low, and to low. And here my program is done. If I click on the start simulation, you can see that the 3 LEDs are blinking together. Here, students will know easily how to the breadboard is used. The breadboard is used to extend. Mustafa is asking, the breadboard is used to extend the circuit in order to put more than one LED, motors, sensors, and so on. So because you cannot directly place all the components that you are using on the Arduino board. Hope it is clear. Thank you, Mustafa. So now I'll move to something more serious, which is how to upload the program from the Tinkercad to the hardware. And here, really, it's a simple task. Look what I'm going to do. I will click on code. I stop the simulation. I click on the drop-down menu here. I will choose blocks and text. And in a click, you can see that the code built in blocks is, let's say, translated to C++ language. So all I have to do is I will select all my code. I will click on my Arduino program. Which is the only program to use in order to upload the program on the hardware. I will select all the previous code and I will paste my code. Sorry. Copy. Paste. And here, all my code is created directly. So no need for students to memorize the Arduino code. And this is a general rule that you are invited to adopt with your students. So here I have in the void setup, I define the pin 12, 9, and 7 as output, since the LED is considered as an output device. And then in the void loop, I'm writing the command to make the LED 12 high, which is mean I will illuminate, the current will pass and the LED will illuminate. So the command is digital write 12 high, 9 high, 7 high. I will wait for 1 second, and then after I will go to 12 low, 9 low, 7 low, and I will wait 1 second. If my Arduino board is connected to my computer, all I have to do is to select I will try. Sorry, the Arduino boards are connected to another computer, so I cannot upload. But in all cases, you have to select tools, port, and select the port where the Arduino board is connected, and then you will click on the upload, which is here. Now, of course, I'm going to have an error since I don't have, like you can see down, I have an error. There is no breadboard connected, but once connected, the program will be uploaded. I will move to my second part. I showed you how to, for those who were not present in the previous Arduino seminars, I will move now to show you two sample of projects, one for the push button. I already did it in order to make a little bit hurry, not to take all the time. So I will show you And you can assure me if you can see my circuit with the push button. So you can see my circuit with the push button, no? Can you confirm me if you can see my circuit push button? Okay, great. So now I will explore a little bit how we did this circuit. So now you know that the LED is connected with this cable to this row, and this row is connected to the ground pin. A resistor is installed on the breadboard, and the other side of the LED, it's connected to digital pin 7. I believe this is what we did previously in the exercise few minutes back. Now it's the time to see how to implement the push button in order to control the LED. Once I press the push button, the LED will illuminate. So I install a push button on the two sections that are internally on the breadboard, as you can see. From one side, from the upper side, let's say, I connect one leg, which is the terminal 1B. It is this name, to the digital pin 2. From the other side, one leg is connected to the 5-volt, and the other leg is connected, is connected to a 10 kilo ohm resistor, and this 10 kilo ohm resistor is connected to the ground. Now we are not going to explore too much how the push button, why we did this circuit, because it's an electricity matter. But all I can tell you, and you can explain it easily to your students, is that the resistor of 10 kilo ohm is placed in order to cut 100% all the parasite of electricity, or the small, the low signals that the push button can make or can pass, even if the push button is not pressed. So like that, we are sure that if I release my push button, there is no electricity signal passing even with low current. So once done, I go to my code and look how the code is simple to write in blocks. So in a forever loop, hope explain the speed appear on screen. Okay, Maria, Mrs. Maria, is there polarity in the push button? Actually, I cannot answer this question. My knowledge in electricity are a little bit, so I do not allow myself to answer this. Zoom user is asking me to explain again the circuit. Quickly, I can say that the push button is connected or placed on, I will show it to you in the, okay, look here. So here you can see also that, I don't know if it's clear or not, but from one side here, from the white cable, it's connected to digital pin 2, and the other two from the other two sides, there is a 10K resistor. One wire is connected to the 5-volt, and the other is connected to the ground. So like this, I will continue on the screen, and then I'll go back to show you how it's working. So like this, the forever loop, I'm setting my button state, which is the button state. It's a variable. I declare it here. Look here, the button state, it's declared as a variable in order to store on it, in it, sorry, 1 or 0. I mean, if the button state is not, if the button push button is not pressed, there is the value 0 in the variable button state. And if it's pressed, there is 1. So set button state to read digital pin 2. Why I set to digital pin 2? Because I connect my push button to 2. And the input, which is read digital pin, so it's reading the status of this digital pin. So it's receiving or not receiving electricity. And then I will go to the if statement, and I will place the if button state is equal to high. It means the push button is pressed. Okay. Then set built-in high and set pin 7 to high. Else turn off the LED of the pin 7 and the built-in LED. So let's click on run. I will press the push button, and you can see that the LED is illuminating. Once I release my press, my click, the push button will turn off. So I believe also, and you can show me on the chat if this manipulation is easy to do with grade 8 and grade 9 as simulation. I'd like to hear from you if you can, or students will understand or will reach the point to create this kind of circuit on the screen. Mrs. Shaima is saying that yes, it's possible. Mrs. Sahar also. Mrs. Nisreen also. Great. So it's done. Now we have to move. We'll be able to do it, Firas. Thank you very much. So once this is done, I will click on the code. I will select the block and text, and you will see that the blocks are generated into C++. So I can read easily how the program is made. And the most important for students is to understand the logic of this code, not to memorize it. Please do understand, not to make this error. Never make students memorize the code of Arduino, because it will be generated somehow. So from blocks, I converted to it to blocks. In the setup loop, as I said before, I'm declaring my input and output devices. So here you can see that the LED built-in, which is the LED 13 and the LED 7, are set to output since they are output devices, and the pin number 2 is set to input. So it's capturing the information for the push button. And for the void loop, we'll go to button state, which is the variable I declared at the beginning of the program. So the button state will hold what will be in the digital read pin. So it will read continuously what is happening on digital pin 2. If you press, it will read high. If you don't press, it will read low. So, and then a condition, which is if button state equal high, so LED built-in high, LED and 7 high, else it's low. So what you will be doing as a next step for students or for higher grades in grade 10, in grade 11, once you give them the hardware to manipulate. So all you have to do is to show them this circuit, Can you see my screen again? Okay. Yes. Okay. Yes. Okay. Great. Great. So here, can you turn off your cameras, please? Okay. So here, you are not asked to give your students the entire pack of Arduino that you may have in the computer lab. I advise you to give your students just what they need for this circuit. All right. So you will give them the breadboard, the Arduino board, few wires, resistors, LEDs, and push button. And here, by the way, I'd like to tell you that for the Arduino chapter, you need a multimeter in order to measure the resistors once they are mixed all together. So in order to know the value of each resistor once they are mixed, so you are obliged to measure one by one and to see the value for each resistor. So once you show this screen on a big screen, or the circuit on a big screen, you will ask your students to build this on a hardware. They will generate the code, and then they will generate the code, and they will copy it to the Arduino program, and then after you will upload it, and I'll be showing you the circuit I prepared right now. So what you can see here is the Arduino board connected to a push button and a LED. You see that there is many wires. It's normal because we are controlling the two push button and the LED. And once I press on the push button, you can see that the LED is illuminating. It's very simple. What I did is like a bridge, or can I ask you by using the mic? Yes, of course, of course. You Zoom user, can you want to ask? Go ahead to ask your question.
Okay. Hello first. Then I want to ask you, so steps, first step, I should let them make by simulation Arduino. The second step, should I let them copy the code? Then third step, let them copy this code, then paste it in the Arduino program. Then it will be turned on hardware Arduino. Is it all right?
Yes. Which grade you are talking
Grade
about?
8.
Grade. How many students you have?
Maybe 11.
11 students.
Yeah.
It's doable. It's doable since the number of students is not too big. So each two students will do one circuit. And in grade 8, you can reach this level of building the circuit on simulation and on hardware.
Thank you. Thank you.
All right. Mrs. Nashwa is asking to display again the real circuit. All right. So as you can see here, the Arduino board is connected to the breadboard. Okay, and then you can see that I've connected the LED. Just 1 second. I've connected the LED with a resistor to the Arduino board, and from the other side, I've placed on the breadboard a push button and make it exactly as I showed you on the screen. And by clicking on the push button, you will see that the LED will illuminate. Okay? Believe me that this type of project will lead the students later on by creating. Yes, of course, Maria, by using the Arduino with not the extension shield, the breadboard, it's much easier and you can control more objects at the same time. It's absolutely, you are absolutely right. So what I was saying that now we are controlling with the push button a LED, but maybe later on with the push button, I can control a motor, I can control a sensor, I can control a water pump. So the concept is the same, but once the students will understand it, it will be easy for them to continue from project to project. I will pass quickly to the second project I've prepared for you, which is the servo motor, which is a really nice project, really simple to do. So you can see that the servo motor, for those who don't know the functionality of the servo motor, this is the servo motor. We have like two kinds of motors. We have a servo motor and we have a DC motor. The DC motor, you have to explain to your students that it is used for ventilator, for wheels, for continuous rotation, and we cannot control the precision of movement. So it will turn, it will rotate as simple. But the servo motor, it's totally different. It can turn only 180 degrees to the left and 180 degrees to the right. And we use such motors, the servo motor, in order to control a rolling shutter of a window, a barrier gate of a parking, or a sliding door, or any kind of movement that needs precision in degrees. So here in Tinkercad, as you can see, I've placed my servo motor. The first pin is connected to, the first one, it's connected to the signal pin, and the signal pin here, it is connected to, as you can see, to digital pin. So here it is connected to digital pin 9. The second one is the power, which is the 5 volt, and the third one is the ground. So for the servo motor, you have 3 cables. You can see they are with different colors, and they are connected. I connected it directly to the Arduino board. No need for the breadboard. So I will go to the code and to check a little bit how we did this servo motor. So since the servo motor is turning 180 degrees to the left, 180 degrees to the right, so here you can insert the loop in a count up and count down, which is a looping to count from just 1 second. to count from 0 to 180, and then from 180 to 0. So to make the two sides. And for each side of rotation, I will print the position of my servo motor on the serial monitor, and I will rotate the servo motor to a position in degree. And here the position, or POS, it's a variable also declared in order to control each degrees in the rotation of the servo motor. So here the position will start in value 0, 1, 2, 3, 4 to reach the value 14, 180, excuse me. And then for the other side, I'm using another count down from 180 to 0. I will run the simulation, and you can see that my motor is turning. I believe that you can see, just 1 second. I believe that you can see that my motor is turning 180 degrees to the left and to the right. And if you click on the serial monitor from down, you can see the different positions of the servo motor while it's turning for one side. Okay, I will stop my simulation. I will go to code. I will click. I will check the option blocks and text. And as you can see, the program is really simple to understand. So I initialize in the setup the serial.begin for the display of the monitor, and the servo is attached to pin 9, and the void loop, there is 2 for the first one to make the position rotation from 0 to 180, and the second one is from 180 to 0. So what is written here is exactly the same as for the blocks that are shown here. So Tinkercad generated my blocks to code. So now I have to copy this code to place it in the program Arduino and upload it, and I will show it to you because I prepared my program. So you can see that my motor is turning both sides. It's amazing, believe me. So students can start crafting later on. So they can craft later on with the project. I mean, if I press the push button, the motor will turn in one side, it will open a door. If I press on the second button, it will turn in the other side, it will close the door. So like this, we will introduce STEAM, IoT, Arduino for projects with the students. I believe that this is the right path in order to reach a good result with the students. Okay, and for those who are using our curriculum, right click or 01, they will know that it is really easy for them. Just I'm trying to show you. It's grade 9. There is a question, or we can use it in rainy days with the temperature sensor. It's raining, then the motor will move to push. Exactly, 100%, Maria, 100%. There is lots of ideas to create or to do with this kind of projects. So just 1 second. Okay, so here, for those who are using our curriculum, they know very well that the illustration is well made, And for those who are still using other curriculums, I really invite them to ask for our curriculum in order to show you how it is clear, how it is motivated, and how it is step guided from one grade to another. Here we are talking about the LDR, which controls the light intensity in order to turn off a light or to turn on a light. Here we are talking about the push button. See how clear it is with examples and with illustration and with step guided and with the ultrasonic sensor. Now, honestly, I have to show you another in 5 minutes, not more, in order to keep, if there is any question from where we get this program simulation to help. Mr. Muhammad, it's tinkercad.com. It's online. It's tinkercad.com. Okay, so I'm going to show you also quickly the simulation of the ultrasonic sensor. Tinkercad.com. Yes, this is it. So this program shows you how we can control a LED using an ultrasonic sensor. So I place my ultrasonic sensor, as you can see. Thank you. Okay. As you can see, there is a 5-volt ground, which is on the 5-volt, the ground on ground, and the SIG on the pin number 7, which will read the signal going and coming. And if we go to code, it's a little bit small here, but I can make it a little bit bigger in order to show you that we are reading the distance measured from the ultrasonic sensor. And if the ultrasonic sensor measure a distance greater than 10, so the LED will turn on. And if the distance measured is less than 10, the LED will turn off. So here I will start the simulation and see how easy it is. Once I click on the ultrasonic sensor, you have like a circle, a bullet circle. You can move it, and like if the ultrasonic is measuring. So once it is less than 10 centimeter, you can see that the LED is turning on and off. So as easy as you can see, if I click on the code, I can take block and text, and I can copy the code, and I'll try it on my board. So now I'm going to just 1 second. For those who are present now, please, I will send in the chat the Google form to fill in order to receive your certificate of participation for this seminar. Can we have the record for this session so we can use it for practice? Of course, Mr. Mahmoud, we can do it. I will do it by the end of the session. So please now go on this Google form and apply, fill the Google form and write correctly your name, how it will appear on the Google form with all the details that are included in the Google form. And now, if you have any question, I'm ready to do it, and hope this session was. I'm clicking on to unmute you. Why it's not working? Okay, so You can unmute yourself in order to ask if you have any question. Please do fill the Google form. You are 74 participants, 73 participants in order to receive the Google form. And if the Google form is not filled, I cannot send you the Arduino certification. If you have any question, please do not hesitate to contact me. I'm here, hearing you and waiting your questions. Any question, please?